All right, so here is Neil's incredibly speculative taxonomy of research philosophies of interpretability. I will give this the extreme warning that I mostly came up with this like a few days ago, so assume that this is mostly bullshit and will wildly vary. All right, so to me, I've got 4 categories that I want to call basic science of interpretability, science of language models, pragmatic interpretability, and let's see, what did I write down on my list? Let's go with okay, let's actually slightly reframe this. So let's break this up into okay, I'm just going to say we're going to have a 4th one that I'm going to call debugging, and then a like orthogonal axis of forwards chaining versus backwards chaining. I will now attempt to explain what each of these means in order. So one take I have heard from many people about the history of science is that the history of science was not driven by people who had like a grand master plan to dramatically improve human welfare and economic growth or to understand specific things. Lots of it kind of happened by accident or from random people screwing around with pretty ideas that magically turned out to matter. And a way you could characterize this philosophy, which I'm going to call basic science, is the way to do good science is to develop good research taste and follow your curiosity. Maybe in a domain you're reasonably confident is impactful. Though, I don't know, some would argue that like number theorists did not expect their work to be useful, and now it underpins large chunks of internet commerce. So who knows? Yeah, the best way to do good science is to develop good taste for ideas, follow your curiosity, don't worry about whether this is part of an impactful long-term plan, because planning is hard. Humans are flawed, and you aren't actually going to make better decisions by doing this. Just let insights accumulate and hope the field makes progress. I honestly think this is an extremely reasonable philosophy. Like, science has made dramatic amounts of progress. Sometimes it was by people who like had a master plan. Often it wasn't. Obviously, there is like gross survivorship bias, meaning that it's hard to say if we just see the people who got lucky, and any given scientist who wants to maximize their impact should be being much more targeted, or if actually this is just the correct way to do science and trying to be too strategic, I just kind of go in circles. Kind of unclear. All right. Science. Oh yeah, and specifically, this is okay. I'm just going to define basic science as what I just wrote here, and then this philosophy of thought is specifically this is basic science of how to interpret models, practice, build case studies, develop our tools, explore new techniques, seek truth and beauty inside models. And I don't know. I have a lot of aesthetic appreciation for this philosophy. Curious for any questions or reactions on the first one? Do people hold this? Do people think it's obviously bullshit?
I have a question. So,
yeah.
Do you think that in interpretability, these basic science methods is more useful because we are in the beginning of the field? Or do you expect it to be constant throughout? It seems that when you don't know what to do, maybe basic science is better.
So it's a bit hard to say. I would weakly agree that I would expect this to matter more in the beginning of the field, but I think the beginning is a really fuzzy concept because it's kind of like, to me, the natural progression of a field is like people invent known techniques, these just become part of the standard toolkit. People who are not experts in the field can learn how to use them and use them to great effect. Ideally, they can become like productionized and systematized and made far more efficient. And then there are also people whose job is to push new frontiers and try to come up with new things. If, I don't know, we thought there was like a single moment where it was incredibly important that we just applied all of the interpretability we had, then maybe it would make sense to just stop really doing this frontier pushing research and focus on that. I don't know if I actually ever expect a moment like that to arise. It's kind of unclear. But yeah. Any other questions or comments? I think there's a decent chance I just totally went out of content for this very quickly. So this is encouraged to be a more discussion-oriented session.
I have maybe a... Oh, do you want to finish? Do you want to go first?
You can go first, then finish.
I have maybe like a hot take criticism that,
go wild.
Like maybe I feel like you could arguably make the case that like a lot of extremely unethical science could be framed under this kind of thing. Like, I have an example, but it's like a little bit
problem solved.
Yeah, exactly. Yeah. easy fix.
Yeah, I don't know. I'm just like, this is just a criticism of any philosophy. If you do evil things, and often it is pragmatically useful to do evil things, at least if you believe certain facts about the world. Most people consider themselves to have ethical side constraints. Not all people consider themselves to have ethical side constraints.
Yeah.
I don't know. Sorry, am I strawmanning your position here?
No, I think that's pretty fair. I guess I'm just like thinking relative to the more like back-chained like ways of coming up with like theories of change and stuff.
Oh, I think backchaining is way worse, personally. So like, For example, a position one might reach if trying to think carefully about the consequences they want to reach, the like kind of final state of the field they want to reach, is they might be like, it sure would be useful if the field had billions of dollars of funding. Maybe I should embezzle people out of $10 billion worth of crypto. And that would be bad and unethical. And also highly ineffective. Fortunately, no one would ever be that stupid. But yeah, I don't know. To me, one of the most concerning ideologies is just fully naive utilitarianism that's like, there is this really important thing, and I can ignore all ethics along the way to that. And even if I'm not confident that what I'm doing is a good idea, expected value theory says this is a great plan. And this is why I am an advocate for the vaguely utilitarian-ish, but with a don't be evil for galaxy marine reasons side constraint, which I think is a much more empirically successful strategy. But yeah. More importantly, I think that people doing backchaining should be able to use any forward chaining strategy, because if it is the best thing to achieve their goals, they should. But anyway, this is a digression, and I will get onto this later. Fanush?
Yeah, my question is more related to the previous discussion that we had, that may be answered throughout, this session. I'm wondering, how do you view mechanistic interpretability and how you differentiate it from explainable AI? Because I think there are some overlaps, like, for example, besides these feature attribution methods, we had concept-based explanation methods in the XAI community. We had, activation maximization approaches, which were looking into the activations, but at those times that these approaches were proposed, we didn't have LLMs, so the problems weren't that much interesting at that time. And now, because of the existence of these really cool models, the problems that we can analyze are more interesting. And I think some of those approaches are still used in the mechanistic interpretability community. So I'm wondering, how do you differentiate these two fields, and why do you think that they are two totally different fields, maybe?
So I guess, quite honestly, I don't have enough of an understanding of what explainable AI is to have an informed answer to that question. I'm kind of just like, yeah, I also just think that arguments over definitions often go in circles without really adding value. I'm just like, I define mechanistic interpretability as work that uses the internals of a model to gain insight into what is going on inside of it and what cognition is happening. This is an extremely broad statement. I am happy for any technique that is like actually useful in practice and provides truth to be considered part of this. I'm sure explainable AI has various tools that I would consider sometimes useful. I'm sure it has a bunch of tools I think are probably just conceptually flawed and kind of useless, as is true of most fields. I expect there are some people who would define explainable AI in a way that's very similar to what I just said. I don't really know. How would you define explainable AI?
For me, the goal of explainable AI is also the same thing. In general, explainable AI for me is equal to interpretability. And so basically all of the approaches or techniques that can be used to better understand the underlying mechanisms that are used by the model to make a decision can be an XAI or interpretability method.
My understanding is explainable AI has a bit more of a focus on designing the AI as well. Like, the interpretability we're doing here is more focused on, like, someone else has made this thing, we now need to analyze it, but we have very little control over the training of it.
Yeah, that's also the case in XAI. I mean, in XAI, we really don't deal with training interpretable models, but we have a model that is already trained, and we want to analyze it and see what the model has learned actually, and what are the decision-making processes in the model. So I think the goal is somehow the same. Maybe the tools are a little bit different.
Yeah, I mean, yeah, basically, there are totally people who like working on interpretable architectures. I don't really know what. Yeah, I don't really know which field they consider themselves to be part of. Some would like to consider themselves part of mech-interp. I mostly think this direction is not very interesting. Some would disagree with me. I don't know. I feel like, yeah, last time I was arguing with a friend of mine about this, they concluded that mech-interp meant interpretability Neil likes. So, I don't know. I want a definition that includes all the bits that are good and not the bits that are bad. Could I just be like rigorous interpretability? This seems like the actual. This is the thing that I actually want to capture with my definition. I don't really care about whether stuff fits into like some categorization, except in that people sometimes find the categorization useful for thinking about a thing, or they find it useful, or it like actually tracks some property that I care about. But like the properties I care about are just, does this give me true insights about a model? Or is this slightly more likely to give me true insights than false insights? Which is really the best you can hope for. And yeah. What else do I think I would say here? Yeah, and it gets kind of messy because a lot of these terms are kind of loaded. Like, mech-interp is kind of a community. It's kind of this label that has hype around it, so people want their work to be considered mech-interp. It's a thing that like some funders care about, though generally the mech-interp funders are unusually competent and don't just fall for buzzwords. But Jasmine?
A question I have, so like what are some signs that something is like truthy to you, or like how can we form our own opinions on this stuff? So like in journalism, like when DeepSeek came out, everyone was like, what do I do? And they're like, I think there's this sense like we're waiting for someone to like tell us what to feel. Like, I mean, I don't want to like cast aspersions on like people in the field, but it's like, so how do you form?
Consult journalists for you.
Yeah. Like what are signals for you though? Like, what are you looking for? Like, what catches your eye? And you're like, this is, I get like a good vibe from this.
It's a pretty difficult question to answer in such an abstract context.
Do you have like an example?
I mean, like one example would be the work I did on Othello, where I have a blog post reflecting on what that research process was like, but in brief, it's like I was like, this paper has this claim, linear probes don't work, but non-linear probes do. This is ridiculous. I want to just go and screw around and see what's going on. How do I screw around? Let's pick like a concrete question. I pick a concrete question and I plot some things, and then some things stand out, like neurons that when patched really matter. And I'm like, oh, that's interesting. What's happening there? And then I have a toolkit for like getting some surface area on interesting things, like maximum activating dataset examples. And then I was like, oh, that's quite interesting. The bold states all have this form, but sometimes they are like black-white, sometimes they are white-black. That's weird. And it's also to do with the priority of the moves. Maybe it's because it's like alternating. And then YOLO, let's train a probe, but it worked fine. And life was good. Much on the general question of like finding truth. Obviously, this is like way too vague a question to actually give a good answer to, but broadly, I would say that ultimately, I find it most helpful to think of things in terms of like making, like, thinking in terms of like Bayesian probabilities. So I have some hypotheses, I have some experiments. I think about how likely outcomes of the experiment are under my different hypotheses, and I like roughly shift how confident I am in them. Typically, I'm not actually like computing numbers, but just the mindset of like, was this more likely under hypothesis 1 or hypothesis 2? Or like, what experiments would distinguish between hypothesis 1 and hypothesis 2? Seems to me like the correct way to do science here. And I think if I was a journalist and then DeepSeek R1 came out and I never really thought very hard about like LLMs, then I just wouldn't even have the context to reason about what the hypotheses should be. I would just be very confused. And I think that's like quite a different kind of science. But often I'll have enough context that I can be like, well, here's a few hypotheses, what could be going on. These kind of make sense to me. I could actually believe some of them are true, maybe, and maybe none of them work, and there's something mysterious not captured by them. But I think that's like a much easier state to do science in. Generally, when I'm in the very confused state, just follow my curiosity and take actions to gain more surface area, meaning do things that throw up additional information and can spark connections, even if I don't know exactly what I'm looking for, is my main advice. I don't know, did that answer the question?
Yeah, I think that was helpful. Like, I was, for us, it's like consistency. Like, we'll just keep asking very specific questions. So, like, I don't know. I guess it's like that's what we do. I was thinking kind of like Cardi B was like, I know a song is good when I start to dance. I was like, what does Neil do? Like, specifically you, when you're like, this has like an air of truth. Like, is there like a reaction you have?
So if it's like, okay, so a few different internal experiences. One is I see a paper, the paper makes some claim, I'm like, this claim is probably bullshit. And I'm like, well, why is the claim bullshit? And I have some arguments. And then I'm like, does this paper present any evidence? Sometimes the answer is no, and I move on with my life. Sometimes it's yes. And then I analyze the evidence, and I'm like, I do not want to change my mind. This is clearly bullshit. How can I generate arguments to falsify this? And then if I try for a bit and give up, then I'm like, oh my god, that's really cool. Or if it's just like a kind of really clear-cut, legitimate experiment that I hadn't thought of, then sometimes it'll be like, oh, that's like a really elegant idea, and that really does distinguish, like that really does only make sense under the hypothesis they have. Honestly, it would probably be better if I felt less of that, because it would be better if I was in the mindset of like thinking about flaws in my own reasoning and ways I can get overly excited about things. And if I do decide something is true, then trying to red team it for a bit, where I find it easy to be in either the mode of this is obviously bullshit or this obviously makes sense. Generally, a lot of the internal experience is around things like beauty or making sense or being surprising and having a sense of like, is this just really messy, or is this clean and I trust my ability to interpret it? Such that I'm like, oh, that's like really strong evidence of something. Yeah. I don't know. I don't.
Yeah, sorry if that was said already because I lost connection for a moment. But what I was thinking kind of about the first philosophy, without knowing yet what you are going to say about the other philosophies, but assuming, I would kind of think that for most researchers, it could be some kind of background philosophy, like something that's also there, but not as important. But so kind of a basic, basic also thing that, that you can approach it us, but at the same time also kind of follow the science of language models and do pragmatic interpretability. Yeah, what do you think?
It's definitely nuanced. So I would be pretty surprised if there was a good researcher who didn't have any notion of like following your curiosity and research taste. I think people vary a lot in how much they think about explicit prioritization. Even people who really care about basic science often do think about the prioritization. Like, you have some hypotheses about a mysterious phenomena, and you want to distinguish between them as efficiently as possible. And like time management and prioritization are crucial research skills. But yeah, basically, like any approach to science, even if you have some higher level goal and guides to your actions, I think you often want to be being a bit more focused or something, or like you often don't always know exactly what to do next, and you want to have like a reasonable set of tactics to follow or something like that. All right, so I am going to move on. Sorry, because that was a dramatically longer discussion period than I expected. This is great. People have opinions. Possibly I am reaching the part of maths where people are actually answering my questions. All right, so basic science of language models. So pretty similar idea to before. They how to frame this? Language models are weird alien organisms. They are produced by gradient descent, and they are capable of doing weird, cursed, confusing things that we do not understand very well. We don't really know what they can and cannot do, when they can and cannot do something, what's going on. They often take actions, and it's kind of unclear whether the actions are justified by like malevolence or just weirdness. Like, yeah. And I don't know. I feel like Twitter is full of language models doing weird, slightly deranged seeming things, and we have no idea what's happening. And I would roughly characterize basic science of language models as like language models may be full of and mysterious structure with a great deal of mysterious structure, with a great deal of uncertainties and mysteries there. Perhaps the point of interpretability is to shed light on this. Example mysteries. Why are thinking models so good? Can models plan? Are they stochastic parrots? I'll take this one off because it's done. Are they... do they have goals? Why are they so sensitive to rephrasings of the prompt? Where does sycophancy come from? Are LLM capabilities learned all at once, or maybe is each LLM capability learned all at once, or not, or gradually? Why does out of context reasoning happen, which is the bizarre phenomena where you do things like train a model to make riskier decisions and then ask it, how risky are you? And it says, I'm so risky, man. It's bizarre. And the most famous recent example of this would be you train it on insecure code, and then it becomes a Nazi. Kind of concerning. I'm sure there's a bunch of other mysteries in language models. Why there's like prosaic ones, like why is 9.11 greater than 9.8? Why are models good at some tasks but not others? No, anyone want to throw out any other mysteries?
I'm curious, are these the type of questions you'd be interested in for research sprints, or like the vibes of them necessarily, or no?
50-50. I'm not currently filtering very hard for things that I think Interp is like actually the right tool for. But if there's any one of these you're particularly interested in, I can definitely comment. And for example, can models plan? Why are they so sensitive to rephrasings of the prompt? Why does out of context reasoning happen? These are like totally things I'm into that I think Interp could help with. Ollie?
Why does GPT-4, well, why do these like image generation language models generate themselves as like sad?
Sorry?
So there's like this trend of like asking models to like paint themselves, like do a self-portrait, and like quite disturbingly, like a lot of the time they're like super sad.
Yep, I'm into it.
Super abstract, obviously, but
Why do search engines gaslight users remains high on my list of eternal mysteries.
Why do different models have different personalities?
Why is Claude so much more dangerous seeming than other models? Do models ever sandbag evaluations? Yeah, lots of fun things. I'm into it.
do you think Claude seems much more dangerous than other models?
I'd say so. In the like kind of scary entity sense, like Claude alignment fakes a lot better than other models do. Claude is a lot more like Claude is aware it's in an alignment eval a lot more. Claude is blah blah blah. It's kind of concerning. We don't know why it happens. Well, I've heard some guesses, but seems sus. But yeah, and yeah. All right, that's enough questions. There are many mysteries. This is scientific inquiry. The mindset here is that of I want to understand the natural phenomena inside these models. It often makes sense to pursue curiosity and anything seeming particularly interesting. But crucially, the North Star is not furthering our interpretability tools, except in this might be instrumentally useful. The North Star is just like, make this model less of a mystery. And if interpretability isn't the right tool for this, you just go use something else. But I'll put this in contrast to what I'll call debugging, which is similar to basic science of LLMs, but more goal-oriented. There is a specific problem with a model. We want to understand why it's happening and ideally fix it. You may start with curiosity, but ultimately you care about fixing the problem, not necessarily understanding it. Though maybe you need to understand it, maybe you need to understand it well enough. Confident you fixed it. Examples. Number of R's in strawberry. The models being really left-wing. The models being really preachy. Why different kinds of jailbreaks work. And it's like a pretty fuzzy boundary between debugging and basic science, because you could have a jailbreak question and be like, why does this work? Or you could have a jailbreak question and be like, what is the like broad phenomena that explains many jailbreaks so I can fix many of them at once, which feels to me more like a basic science question. But like, I think it's quite important as a researcher to know how much you like have a clear goal that you should be holding yourself accountable to, versus your goal is just maximize information generated per unit time, and the sole thing you should be asking yourself is like, have I learned things that feel valuable? And I think these are like quite different questions. All right, any questions on those two? Ida?
Just like, well, just the mindset does make a difference, maybe a little bit. But for the exam, for what you approach, really, couldn't you, like for the questions that you mentioned, couldn't you actually totally map, like, how should I say that? Say they could be either, because it depends just on what you call a bug and what you call a feature. For example, like,
Yeah.
yeah.
So it is more of a mindset thing than a question thing. I think there are many phenomena that aren't bugs. So like, I don't know, if I look back at this list, why do different models have different personalities? I don't consider that a bug. I don't think there's anything to fix. I just think it's kind of interesting. Or like, how do the things done in post-training affect the kind of personality you end up with? So I would consider debugging questions to be a subset. But like, really any question is a thing you can go and explore.
Okay, yeah.
Personally, but yeah. Yeah. Yep. What else? Yep. Any other comments, questions, theses, critiques?
Would you say that these mostly differ by what your motivation is, rather than necessarily how you act, like day to day, what work you're doing?
To me, so it partially depends on like scope of project. If I'm doing a week-long project, the motivation is like pretty damn important to how I'm spending my day, because I'm just like doing lots of small experiments and I'm asking myself things like, am I learning things from this? Is this feeling interesting? Versus, is this helping me make progress towards the problem? You do often want to begin a debugging question by treating it like a basic science problem and gaining understanding. But I think you want to be more focused and more ruthless about prioritization. Though you can conceive of basic science problems as just a like special form of this, of like debugging. where the bug is just like being confused. Another crucial thing is that with debugging, trying solutions is like the point, while with basic science, trying solutions is purely a form of validation that your understanding is correct. But I don't know.
Yeah, that makes sense. Thanks.
And I don't know. Seems probably important, maybe. But yeah. And then words. Yeah, and then pragmatic interpretability, basically what it says on the tin. You have tasks you would like to solve. You try to solve them, no holds barred. If interp is the right tool, you use it. If it is not the right tool, you don't use it. You might do some like R&D on your interp techniques in the same way that you would do R&D on like any other technique you're using on a task you care about solving multiple times. So how to articulate this, maybe your goal is to solve concrete tasks, and if interpretability is relevant, you use it. If it is not, you don't. If you want to do research and development on improving your methods, in general, you might do it for interpretability if you think there's good returns on it. But ultimately, your goal is to have practically useful impacts. And there's in which, there's a sense in which debugging is kind of like the thing halfway between pragmatic interpretability and basic science of LLMs, because it is like solving a problem, but the solution is a lot more understandings flavored. Sometimes useful. Yeah. Sometimes we use the term model internals for something that like encompasses this. One taxonomy I kind of like is that interpretability is reserved for things where understanding is the sole criteria, while just using the internal activations of the model is like also an interesting field, but is kind of like a highly overlapping different set. And there you might call it model internals. It includes things like probing, steering vectors, often things like you might want to do early stopping, where you just stop at a certain layer and just directly apply the unembedding. You might want to do anomaly detection on the activations, or maybe you want to like use an SAE to like create a good user interface, but your main goal is making a good user interface. And yeah, so I think there's an obvious so I think so like I used to be, I think, pretty opposed to this philosophy. I've come around to it a lot more. I think to me, the two core things that make this somewhat appealing are that A, it is just really hard to do good science. It's really easy to get nerd sniped into random rabbit holes, or to try to follow some ambitious plan, and then you made some like false assumption early on, and the whole thing kind of crumbled to pieces. And I don't know, seems important to figure this one out. And yeah. What do I think? Words, things. Yeah. Ultimately, just being like, I want to solve a problem. If Interp is the right tool for this, I will use it. If it is not, I will not. Feels very pure to me, in that I think that if you find real insights, this is like, if you use interpretability and you have taken this seriously, I feel a lot more confident that interpretability is actually adding meaningful value there than I would otherwise. The other reason would just be, look, I want to do interpretability so that it is useful for making AGI safer. I do not know what this looks like. I do not know what time frame we need this on. I do not know what the most important use cases are, or like which approaches to interpretability actually matter. And picking tasks that just seem generically kind of helpful today, like classifying states of a model or something like that, and just getting really good at them, might be a good way to prioritize the kind of work that most matters. Even if I don't care about the task that I'm studying, the like feedback, practical experience, information on prioritization or what works might be general enough to actually transfer. We are currently experimenting with this at work with our new applied interpretability team run by Arthur. And yeah, 2 reasons for why this is appealing. One, what was I just saying? Hard to know if what you're doing is real, actually useful, is a kind of real. And then secondly, useful for prioritization. There's a lot to do and perhaps not much time. Who knows? But yeah. Anyway, yeah, thoughts, critiques, hot takes.
It might be helpful to have some concrete examples of tasks which are not debugging tasks that fall under this philosophy.
Cribbing for anything, e.g. harmful user intent, e.g. political bias, e.g. being used to make spam, e.g. being used for illegal activity, e.g. hallucinations. Maybe steering or conditional steering. This requires it to actually work, which is not going very well, but who knows? There would be one thing that could be interesting that I haven't really tried is anomaly detection based on model activations. Another might be identifying the fine-tuning data points that led to a problematic behavior with training data attribution and other practical examples. I mean, I'm sure there's various things you could do that I do not consider particularly safety relevant, and so I don't want to emphasize, like try to make models that like have fewer parameters but still run well, or design better architectures or stuff like that. Like, fuck that. Any other questions or hot takes? All right. And yeah, closing with forward chaining versus backward chaining. So I broadly just see these as like two fairly different high-level philosophies of how you can choose your actions. This is like not anything specific to interpretability. It's more just like yeah, just different life philosophies or something. So backwards chaining is similar to like theories of change or theories of impact. You identify some outcome that you care about, and then you strategize what you can do now to eventually achieve that outcome, and then go out and try to do whatever seems on the critical path. You focus on things that seem good in the short to medium term, like obvious extensions of interesting research, things people are missing, key opportunities, doing things that seem robustly good, like building general tools or knowledge or data or infrastructure or resources. And I don't know, these are like quite general philosophies, but in the context of interp, you want to eventually be able to detect deception or debug potential highly problematic behavior or verify a chain of thought of a frontier model is faithful. What is on the critical path from here to there? For interp, what are the obvious ways to build on existing research? What are people missing? What are the key current mysteries? Do any seem tractable with existing tools? If there are new tools, where could they be productively applied? Do you have any research ideas that you think might work now and be robustly good or useful or interesting? And why is my text to speech so bad at punctuation? Yeah, and I don't know, I am like quite sympathetic to both of these philosophies, and I think I have seen people who I think make the mistake of being way too into one of them and not respecting the other. Like, I think you do just, in fact, do better science if you are focused on doing good science. And I think that I personally have had quite a lot of success with much more forward-chainy style research. Like, oh, SAEs seem like an interesting tool. What can we do with them? What can we learn about them? How could we verify if like they're interesting or not? And I comparatively find it much harder to do the more creative version in thinking about things like what does it actually take to get from here to be able to solve deception, etc. But also, I think that there are some pretty high-level takes that I have that follow from back-chaining style arguments, like I care about my work being used by catastrophically dangerous frontier systems. It's extremely unlikely that I get them to use my interpretable architectures idea, so why even bother? Or opinions about like what cost of different techniques would be acceptable, things like that. And I don't know. Seems suboptimal. But yeah. You admittedly could characterize my views as anyone who is more in one of these directions than me is wrong. But it isn't clearly true. And yeah. All right. Questions, comments, pushbacks, musings, rants. I'm bearish on interpretable architectures because I don't see any good reason to expect it to work. And I think that even if it worked, it doesn't seem useful because you have to convince people to use your thing. And this is extremely politically difficult, even if it doesn't have a significant performance hit. I mean, if it has a massive performance gain, then it's easy-ish. But that seems bad in other ways. And I also just think it's extremely unlikely that you have a thing that makes things dramatically easier to interpret and has like big benefits. Performance.
Reasoning models.
Fair point.
I'm sure it's the exception rather than the rule, though.
Yeah, that's a good counter argument. Yep, I think that projects that have that flavor do seem like the kind of thing that could politically work. Though, admittedly, I think in this case, the thing that actually worked was OpenAI made a big splash and everyone else got really embarrassed and invested way more resources and political will into it. But yeah, Tim?
Yeah, I guess my case for interpretable architectures is maybe if you think that all sufficiently large networks learn the same set of mechanisms, and you can understand the mechanisms better in an interpretable network, and then you can go look for it in your other network, because now you have like some sort of better idea of what to look for to begin with, etc.
Maybe. I'd bet against, but I don't really know. I think another question is how much to expect there to be like really clear understandings that you can gain from this versus things being like much more cursed and weird. But yeah. So all right. Any further takes on this? Cool. No one has any opinions. All right. In that case, suggested exercise. Everyone takes a minute to think about which of these philosophies they feel most inclined towards and puts their top one or two in the chat.
Can you share the slide page so we can review the subpoints?
Probably. I will reset the time. All right. Put your takes into the chat. Ooh, this is a fun mix. I love it. I particularly appreciate all these self-aware contradictions. All right. Anyone have any interesting reflections they want to share? All right. No one with any thoughts.
Do you think your 4 points are they're obviously ordered? Do you think there's a sliding scale here rather than like distinct categories?
Oh, yes. It's true of every categorization, right?
I don't know if that's true.
Most categorizations about complex real-world phenomena. I'm failing to think of a research field that I think has like a really crisp categorization with no edge cases. But yes.
Well, it would not be linear. Sorry, more my thinking there.
Oh, sorry, then I didn't understand the question.
So there might not be one sliding scale. There could be many dimensions of like, here are ways people disagree with each other.
Oh, yeah, totally. That was going to be the next part of the talk. All of the other sliding scales where people argue that are not covered by this.
Right, well, I've teed you up then.
Yep. Victor?
Yeah, I think there are like many interesting questions on the basic science because we still don't know a lot of things about how like the models work and interp work. I think I'd be more interested in debugging if I had a better grasp of what are some pressing or dangerous current issues we don't understand. And I'm not completely sure how to improve this feeling of this is a limitation of current models and we really have to fix it. Because we see this, for example, like count the number of letters but what about the most pressing stuff that's concrete and goal-oriented?
Yeah, so I'm admittedly in the annoying situation where I want my team to be doing glorious debugging projects, and finding good things to debug is one of the big bottlenecks on this project. But I have the conviction that there will be important things to debug between here and AGI. These models are too weird. Though I do admittedly think that a lot of the most pressing near-term work looks more like basic science of LLMs. And what I'm actually trying to do is see if I can make it so that if the Gemini people have any interesting problems, they forward it to us. But yeah. What else? Yeah, it kind of does feel like a lot of the issues are either trivial or more like a science question. So, like, I'm really interested in the alignment faking stuff from Anthropic, though it's not very interesting to do interp on a thing when if it's doing chain of thought to spell out its evil plan, because finding this is the word evil latent is not the most exciting of findings. But yeah, this is more of a like, what's going on? What is the flavor? Is this real? Yeah. Yeah, maybe it's just like the weird middle child of pragmatic and basic science of LLMs, and most things that are interesting also just fit fine in one of those categories. Who knows? Was it, I think, Ollie then Tim?
I think Tim was first.
Oh,
If
Tim?
he wants to go.
Oh, sure. Maybe a spicy question, but how do you sort of think about debugging as like distinct from capabilities work? Or yeah, I don't have a good way to ask the question, but in general, how do you sort of think about those two trading off or something like that?
So I think I am generally much less conservative about does this advance capabilities than many of the loud online safety commentators are, because safer systems are just way more useful. They are like more steerable, they are more economically valuable, they are less risky to the company, and thus, if safety researchers are doing their job right, capabilities should also be advancing as a result of our work. I don't want to just advance capabilities, like I think that's clearly bad, but I think that work that advances capabilities via genuinely advancing safety is great. And it's just basically impossible to have good safety work that doesn't do this. I mean, you can just like hide your safety works in a box and never tell it to anyone, but my personal take is that that is not an effective strategy, because A, you learn quite useful things from trying to have your techniques be used by real practitioners who don't care about interpretability, and B, if I want DeepMind to actually use interp to make its system safer, that means that I need to, well, it is extremely useful if it's like already got lots of precedent set and there's practice and there's infrastructure for it and people are using it, etc. So yeah. My read is that many safety researchers in industry are way less conservative about capabilities advancements than many online commentators, though there's an obvious massive selection effect there. But yes, that is my spicy take for the day. Pushback welcome. All right, Ollie?
Yeah, how do you think something like ambitious interp or like enumerative interp or something like that fits into this? Like I saw a couple, like I think my response in the initial form, I think I saw a couple of other people's responses were something along the lines of I'm interested in interp because I hope that it achieves something that's doable but also as close to rigorous as possible for like safety guarantees.
Yeah. This is a thing about which people disagree. My personal take is that we might get it. We are never going to actually achieve that kind of thing. We might get a decent approximation. But this is very different and sad. And I think that if you get too anchored on the like high reliability points, you start making unpragmatic decisions, and this is sad. I think that in terms of how it fits into the taxonomy, so partially this is just like a little bit orthogonal. Like the things I outlined here are kind of like how to make progress, or like how to approach making progress. And then this is like how to think about the kinds of progress that you aim for. So like, it's possible that someone could just be like, I want to get to enumerative safety. We're clearly very far from this. We are missing fundamental insights. The best way to do science is just basic science. Someone's going to fuck around. They also might be like, I think that basic science is not the right way to do this. we should be being pragmatic, because that is the best way to make sure we are gaining real insights. And this will like help us ratchet our way up to something that's actually useful. Also a valid perspective. And yeah, I think part of it are just like questions of philosophy of science. Another one would be, yeah, I mean, obviously you can have pragmatic interp as just the end in and of itself. Like, you want to use, it's like one thing people might care about with interp is using it for monitoring. Like, you have a deployed language model and you want to cheaply look at what it's doing and raise the alarm if something really bad's happening. You might want the first line of defense to be a probe, because probes are incredibly cheap. And this seems cool. Yeah. What do I think? I think that yeah, there are like some theories of impact where like there's just some pretty obvious tasks we could be good at now. And there's some theories of impact where you're just like, I have no idea how to do this. I believe it might be possible, but this is a big, ambitious bet. What is the right way to make big, ambitious bets? And, you know, like, how to tell when a model is being deceptive is a like classic thing many people care about. And I think that, yeah, classic thing that many people care about. And I think that you could argue that we have some reasonable idea of how to go about doing this with techniques like probes. You could argue that we're confused, and so what we should do is basic science on like things that might be deceptive, or like model organisms we fine-tuned to be deceptive-ish. Or you might argue that like we need high reliability, so we need to do basic science. I think it is useful to have these mental buckets, because I think people often talk past each other, where they're implicitly assuming one philosophy of progress and someone else is pursuing another. And I think my personal take right now is that I'm most excited about basic science of language models and maybe debugging, but that I'm like somewhat agnostic about what the best way to make progress is. And there's probably decent arguments in all directions. And it's very sad, because I like being judgy of other people's research, but oh well. So Ida asks, is our final goal just to understand rules of control? You'll get a different answer from every researcher you ask, but my goal is understanding. The reason I say this is because I think that most fields of machine learning are about control and not about understanding. Very few fields of machine learning are about understanding. Interp is one of them. I would rather focus on the thing that interp is one of the few tools we have than the thing ML people are actually reasonably good at. I think that it's possible, I will change my mind on this, maybe interp just turns out to be really good for like things that generalize really well out of distribution. But the track record for just add more data and GPUs and layers is pretty good. It's really annoying. It's going to put me out of a job. But yeah. And yeah, I would hope that if we understand the thing, this is useful for controlling it. Like, I think one crucial reason that basic science of language models is interesting is that I think it can enable lots of other research on them. by just discovering facts and helping us be a bit more grounded and concrete. But I don't know. All right. To close, I'm going to try listing some things people argue about. So one would be time horizon that you want to be useful on. Like, are we trying to like do useful things in like immediately, in a year, in 20 years? This clearly has different implications. I personally am a bit confused that Anthropic is pursuing what to me feels like a basic science approach, while also claiming like 1 to 2 year timelines. But you do you. And yeah. So obviously the kind of like underlying thing behind a bunch of this is like philosophy of science. And one thing that I think can underlie this is level of faith in complex plans / arguments. There's a great blog post on sequence versus cluster thinking that I think does a decent job of capturing this. So the idea here is, suppose I say, I want to be able to detect deception in models in like 5 years. Here is my plan. I am going to develop Uber SAEs, and then I'm going to use Uber SAEs to, and then there's going to be the following problems with Uber SAEs, and I'm going to fix them, and then I'm going to attack circuit analysis, and then it's going to be glorious. Some might think that we can actually form decent plans at that level of abstraction. Some might think, no plan survives contact with the enemy, but it's useful, and it's much better guide than nothing. And some might think, this just seems obviously doomed. I'd much rather do research where there's just lots of different reasons for thinking it's a reasonable plan, even if there's no one smoking gun reason that I'm really confident in. I personally am more partial to the second kind, like do things where lots of reasons say they are good, but I don't know. I would like your takeaway from this talk to be more the breadth of options and philosophies than any particular one being the right philosophy and option. I personally think that most people who try to find the right philosophy or option end up highly confident in one perspective. There is not a significant correlation between which perspectives they end up highly confident in, and thus the correct position is to be good at modeling different perspectives and adopt the correct one for the correct situation. And there's probably not one that is just the correct approach, though sometimes it is better to commit to one approach at random than to lukewarmly commit to 4. Okay, what are other sources of disagreement? So what I haven't really talked on much is like qualitative versus quantitative evidence. So I think that, what was the shocked face in response to? So yeah, qualitative. Yeah, so qualitative, just lots of case studies, lots of examples, lots of like human interpretations of specific phenomena. Quantitative being, here is a metric. I will define a metric. I will measure it in detail with a large sample size. I will make pretty graphs. I will have a big sample size and do lots of things. And in my opinion, standard machine learning does way too much quantitative stuff. And often your metrics are bullshits. And if you don't do qualitative stuff, you don't notice this. Or like often your metrics are extremely ambiguous, but having a few case studies can illustrate this a lot. But then often papers are way too qualitative, where they just have like a small number of examples they analyze in lots of detail. But it's super unclear whether they looked at like hundreds of examples and picked the 5 that were prettiest, or this is the first 5 they tried, or they, I don't know, have an interpretation that's like kind of superficially plausible, but if I sat down and thought about it, I could come up with like 5 other ones that are equivalently plausible. And generally, as a very general rule, the quantitative crowd tend to be more about like pragmatism, and the qualitative crowd tend to be more about like basic curiosity-driven science, though it's kind of complicated. And I think in particular, one like thing that is very easy to get confused about is that lots of people, me included, talk about the importance of downstream tasks, and like verifying your research on actual use cases. But I often do this from the perspective of being a good basic scientist. It is just that picking a task and doing something is evidence that your technique works, or that your insight is truth. And separately, there is people who just have a task they pragmatically care about. And they don't really care about interpretability, but they're just like, do my task. I care about my task. And superficially, these can look very similar, but are quite different. Anyway, that was mostly just a rant. Personally, I think that the correct approach is to have both qualitative and quantitative examples. Like have some examples, analyze them qualitatively, display some key observations, motivate some metrics, and then show the metrics properly at like larger scale and that things are representative. In particular, make sure that when you're presenting your results, you include some randomly selected examples, so it's clear you're not just adversarially cherry picking. This is very much useful advice for producing a sprint project that I will like and think is not bullshit. I think, yeah, many people go way too far in one direction. And you want to be doing a mix of both, and ideally switching between them as you go throughout the project. In my opinion, Anthropic papers could do with being a lot more quantitative than they currently are. Though they do a fantastic job on the qualitative side. All right. What are other philosophy differences? Well, I mean, one obvious one is people who care about AI X risk/safety and people who intrinsically just care about the science. This is one where I'll just totally give a value judgment of I care about existential risk from AI. I think that is the correct side to care about. But as an empirical statement, you know, there's a bunch of people in the field who just care about the science. They often do good work. I would like it to be a functional field that can have both kinds of perspectives in it. But these people will have very different views of backchaining, and I don't even know if I want to say they're like specifically drawn to like one of these perspectives. There's level of faith that there is deep truth to uncover. Like, do people think that there is like actually some deep structure in these models that if we understood would make their behavior make way more sense? Maybe make it so that we could ambitiously understand everything versus people who are like, yeah, obviously that's doomed. But like I can make some progress and some traction, and this is kind of interesting, and see how they can go from there. And other interesting disagreements. So, I mean, when I argue with researchers about papers, often, if they're like a competent researcher, the disagreements will boil down to just things like different priors. Like, I find a claim surprising, and I'm just like, this is insufficient evidence. They find it unsurprising, and they're just like, this is fine. Or vice versa. Or I'm like, this method just seems incredibly complicated, and they're like, this has this really strong advantage that makes it worth it. Oh, that reminds me of another one. How important is it to have techniques we will be surprised by, i.e. unsupervised versus supervised techniques. Yeah. And I don't know. Do I have any further things to say here? Yeah, there are like some people, this is like a very prevalent view at Anthropic, whose position is AIs will be weird, cursed, and messy inside. We aren't going to be able to guess in advance what it's going to look like. It's really important that we have tools that can surface hypotheses that are true, but we didn't expect. I have some sympathy with this, e.g., I did not expect modular addition to be done with random mass discrete Fourier transforms, though conveniently after the fact, all kinds of people are like, that was obvious. But also, I don't know, if I was like actually sitting down and brainstorming a bunch of hypotheses and checking them, I feel like I probably would have come up with it eventually. But, you know, things that surface hypotheses earlier is good, and especially if you're concerned that models will get much more chaotic and weird, you might care more about this. It's kind of a mess. All right, any closing questions?
I just had a question in the chat
Oh.
about your like criticism of, for example, Anthropic doing basic science with short timelines. Could you make the case that like a good that they might expect something like, they might be like partial to the argument of make AGI, then have AGI solve alignment, and that the best way to set up for that is to do a bunch of basic science in preparation of this, like a bunch of basic science, a bunch of basic techniques, and then give a bunch of very intelligent AIs these techniques to hopefully finish that off in a sense?
Yeah, I think this is like a reasonable perspective, and I agree this is an argument in favor of basic science. I think this is a reasonable perspective. They might have this perspective. They've not expressed it to me. It's not completely obvious to me. Like, it's just hard to predict which cognitive tasks the AIs will be good for. But I agree this is like a plausible take.
Like especially if Mecinterp is somewhat verifiable, if you can RL have an RL Mecinterp thing that has a bunch of basic techniques and goes and optimizes the heck out of interp.
Yep. Yeah. Well, I mean, there's the automated researcher, and then there's the automated like practitioner using the interp tools on a given phenomena. Which I personally would just consider like an example of a research tool or something. But I do think that building tools that an AI could use to interpret another AI is like a totally worthwhile direction of research. And I think that doing research that matters most in worlds where we get like powerful AIs quite soon is pretty reasonable. Useful eventually. And I've also been finding it interesting recently, thinking about whether the potential prospect of like really good coding assistants should change my hiring criteria and like make me underweight engineering skill and overweight research skill more.
Definitely don't change your opinion that way.
But yeah. Anyway, all right. Closing question. Raise your hand if you think this talk was useful enough that it's worth the effort of writing into a blog post. 50-50. I'll take it. Thanks. All right. If there are no further questions, then let's wrap up. This was fun. Thanks.
Thank you.
Thank you.
Thanks.